friends, we're back and it's section 5.2 today. I'm going to ask you to learn from this video how to simplify polynomials by doing something called combining like terms. So what in the world are like terms? So what do these terms here, 3x, x, and negative 8x, all have in common? And if you said that x is the variable, you are correct. And how do we actually show that they're in common? Well, visually, common things should look the same. So if I wrote down 3x in terms of its algebra tiles, you would see that there are 3 rods. Notice the x would just represent 1 rod. And negative 8x would be 8 of these rods. 4, 5, 6, 7, 8. But they would be dark. But regardless of the color, the shape is the same, and that's why they all are in common. Now, when they are common, we use a special name in math. Common is too many syllables, so we call them like terms. Okay, like terms. Now, notice the terms negative 4n and 5n squared, even though they have the same variable of n, are unlike terms. Because if you were to model these, remember the n are the rods and the n squares are the big squares. They don't have the same shape. So please, 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 and I'm going to tell you, my grade 12 students still get this wrong sometimes, but please tell me these are not like terms. Okay? So, for example number 1, in each group, can you please circle all the like terms? This is x squared. Anything else with x squared? Nope. Okay, this is an x. This also has x, so these two definitely should be the same and are like terms. X cubed, nothing else is x cubed, so sorry. Okay. Part B. Okay, x squared. Yeah, I see that. Anything else with an x squared? Oh yeah, this 7x squared. Anything else with an x squared? Oh yeah, this negative 2x. That's cool. Okay, 6xy. Don't see anything else with xy. Don't see anything else with just x. So that's it. Those are the like terms. Okay. My question to you, looking at example 1, is does the number in front of the variable affect whether or not you have like terms? So, does this number here affect whether they have like terms or not? And the answer should be no way. No. Okay, there's no effect. What does matter then? Okay, let me say what does matter is that the variable, okay, in like terms are the same. So it's not what's in front, it's what comes afterwards, the variable part. So the x squared, the x squared part, that's what matters when we're talking about like terms. Okay, so we've done it, algebra, but I want to show it to you using the algebra tiles as well. We're going to also know and show you how to combine them using algebra tiles. So to do this, I want you to know one particular fact, that opposite tiles have a combined value of 0. Meaning if I have one white and one dark and I put it together, it's called a 0 pair. Okay. So, you see here, this is like negative x squared. This is like positive x squared. And if I add them together or put them together, that gives me 0. Same thing here, negative x and a positive x. If I add them together or combine them together, this becomes a 0. Same thing here, negative 1 and a positive 1. If I combine them together, this becomes a 0. And that's what I meant by the statement above. Alright, so let's take a look now on page 2. And I'd like you to take a look at our first polynomial, which I'm going to ask you to simplify. Simplify means make it look nicer, make it look simpler, but it represents the same value. So here is our question. It says 4x plus 1 minus 2x minus 3. Okay, so Let me show you how to do this with algebra tiles and the symbols, and I'll do it at the same step so you can see the connection between the two. Let's just represent each term. So 4x, that would be 4 rods. 1, 2, 3, 4. Plus 1 small square. And then minus 2x, that would be 2 negative rods or 2 dark rods. Minus 3, 1, 2, 3. And you should draw this out too. Okay. That's the algebra tile representation of the symbols 4x plus 1 minus 2x minus 3. So, to simplify, I want you to rearrange to group similar terms together. So what I mean by that is, let me draw all the rods together. So I'm going to copy the 4 white ones. I'm going to put the 2 negative ones just below it. Okay? And then I'm going to have a white small square and then 3 negative small squares below it. Okay? So rearranging in terms of algebra, now what I'm saying is let's put all the x's together, so 4x minus 2x, and let's put all the numbers together, plus 1 and then minus 3. Okay? Step 3, I'm actually not going to draw, but I'm actually going to do something. Okay? I said remove the 0 pairs. So when I remove the 0 pairs, here's a 0 pair. Remove it. Goodbye. Remove it. Another one. Goodbye. And then I can remove this 0 pair, right? Goodbye. And so that's what I just did here, okay? Removing 0 pairs. And so what's left? Write down the remaining expression. So the remaining expression I have are 2 white rods. And I have 2 shaded squares. So what does this represent in algebra? Well, 2 white rods are 2x. And then 2 dark small squares are minus 2. So can you see how I just combined this together? So 4x minus 2x gave me my 2x. And then the 1 minus 3 gave me the negative 2. So in a sense, what I did was I combined like terms. I combined all the shapes that were the same into one group, and all the shapes that were another shape, I guess the small square, into a separate group, and then we simplify. Okay? Alright, I hope you understand this. I know it took me a while to do it, but the visual I think helps. Okay? Here's my next question. Mr. Lee tutee, or what's a tutee? That's a person that I tutor. So outside of class time, I might have someone that comes for extra math help. That person is called a tutee. Mr. Lee's tutee said he's not too sure if x plus x is equal to x squared or 2x. Which is it? So x plus x, is it x squared or 2x? Which is it? You can explain in answers or using algebra tiles. I would actually use algebra tiles because I like pictures. What's x plus x? Well, that's a rod and another rod. So, what's x squared though as a picture? Well, that's the big square. So I don't think it's x squared. But what about 2x? 2x is 2x. So, 2 rods. I think, therefore, this picture is the same as this one. So, x plus x must equal to 2x and not x squared. Okay? So notice once again, when you have like terms, you're combining them together, you're just grouping them together. X plus x equals 2x. So when combining like terms, please make this following note. The degree of the variable does not change. See, if I had said the answer was x squared, the degree here was 1, then it became 2, doesn't make sense. Okay? Only the coefficient, though, that's the number in front of the variable, only the coefficient does. So to combine or simplify like terms, and this is key, so please highlight this or underline, add and subtract the coefficients of like terms. Unlike terms, you can't do anything about it. Just don't combine it at all. Okay? Alright, let's try some examples on the last page here of our notes. So now I'm going to ask you to simplify the following algebraically by collecting like terms. If you want to use algebra tiles to show the visual, you can, but I'm hoping that by this stage you can get away from that. You're going to have to know both, but in higher grades I'm hoping you don't have to draw pictures every single time. So 4m plus 7m. Remember, these are the same variable. So if you look at the pictures, these are all those rods. So 4 plus 7 are 11 of them. 11 take away 2, that's just 9. So this is just 9m. Similarly here, these are all rods, right? Y, degree is 1. So negative 3 plus 9 is 6. 6 minus 10 is negative 4, so negative 4y. Okay, now for part C, notice we've got letters and numbers. So we've got rods and the small squares. So what I'd like us to do, first of all, is just group them together. So let's group all the letters together, or variables, and then let's group all the constants together, the numbers. And then we can now combine like terms separately. 3n, take away 2 n's. So 3 rods, take away 2 rods, is just 1 rod, or 1 n. 8, take away 11, is just minus 3. And there's our answer. Okay? I'm going to ask you to try the next ones, D, E, F, okay, G, and maybe even H, because I think you know how to do this now. Alright? So pause the video, try them first, and then come back to double check your answer with mine. Two minus 5, that's negative 3. So negative 3g. Negative 7 plus 12, that's 5. This one has x and y, so let's just put all the x's together. That's one variable. And the y is a separate variable. Let's put those together then. Okay. And then I'll combine the x's together. Negative 2 minus 5 is negative 7. 3 minus 8, that's negative 5, so negative 5y. Okay. F, same thing. Let's combine like terms. I see d squared is degree 2, so let's combine all those together first. Okay. Then I see d's, so that's negative 3d and 7d. And then I see a 1 just by itself, so I'll leave it like that. Now I'll combine like terms. The d squareds, 4 of them plus 6 of them are 10 of them, so 10d squared. Negative 3d plus 7d. Negative 3 plus 7 is 4, so 4d's. And then the plus 1 is just by itself, so I'll just leave it as is, plus 1. Alright, let's look at G. I see an R and an S, and then an S squared. So R's are alike, so 5R minus 2R. S's are alike, so plus 6S minus 9S. And then finally, I got this plus 3S squared. And so now combining 5R minus 2R, that's 3R, 6S minus 9S, minus 3S, and then last but not least, I got 3S squared. Okay, H is the same, guys and gals, just lots of stuff. Yikes. So I'll do the x squareds first. I'm going to cross it out after I've written them down so I can see what's left over. Okay. Any other x squareds? Nope. Okay, so now let's do the x's. So I got 10x, I got this minus 2x, I got this plus 11x, I got this plus 8x. Cool. And finally I've got my numbers, so 4 and also minus 4. So just by crossing it out, I can now figure out I've taken care of every single term. Now, let's go and collect like terms and simplify. Negative 6x squared plus 6x squared, that's negative 6 plus 6, that's 0. You could write down 0x squared, or better yet, just leave it out. 0. Okay. 10 minus 2 is 8. 8 plus 11 is 19. 19 plus 8, there's 27x. Good. And then I've got the constants, 4 and negative 4. 4 minus 4 is 0, so I guess that's it. It's just 27x. Good. Now, just one little note, one last thing, and then we're done for today. If a term contains two variables, okay, you are able to combine it with another term with the exact same two variables. The order does not matter, but they need to have the same exponents on each variable. So what I'm saying is this: if I see xy and I see yx, they are actually like terms, even though the order is different. You can combine them together. But if I see xy squared versus x squared y, notice that the exponents on each variable are not the same. See, on the y squared here, you got a square. On the y over here, it's a 1. They're not the same. So in these two cases, these are unlike terms, and you cannot combine. Okay? So looking at example 5a, the question is, can the following be simplified? Then if so, do it. So notice you got 4xy, and then yx, the variables are the same. The order is not, but are the exponents the same? They are. So you can do this one, yes. 4 plus 8 is 12. And you can write it as 12xy, or you can write it as 12yx. It doesn't matter. Most math people like to put things in order, so let's go 12xy. Okay. Look at part B. The letters are the same. That's good. But look, the first one's a squared. This one is a to the power of 1. So, the exponents on each variable are not the same. Can't simplify. So the answer is no. And here, whoa, lots of stuff. So let's see, xy. Oh yeah, yx, that's cool. We can combine that together. I'm going to write this as 2xy right now. So those are gone. Oh, 2x and 7x, I see that. So let's put those together. And then minus 3 and plus 4, we can put that together. So you can definitely simplify this one. I'm actually doing it now, and you should too. 5xy minus 2xy is 3xy. That's those two combined together. 2x and 7x, that's 9x. And then negative 3 plus 4, positive 1. We're done.